everyone. I'm Dr. Amy Prue, and I happen to work with Ron Giesbrecht, and I am CFWI's resident food science professor, and I happen to teach sensory analysis as well. And Ron and I were having a discussion via phone about your data collection for the QDA work that you have been doing. QDA is quantitative determination analysis, and Ron asked for a little bit of insight about the statistical evaluation of this data. So I took the chance to oblige, since it's COVID time and we are having some time at home to reflect on how to teach our content a little bit better. So I happened to receive this data set from Ron, and one thing that I really want to commend everyone on is just how lovely it's organized, and it's very clear what the experiment was. Now, here's one helpful hint, and I want to start with this. When going in to do experimental work on food products, or any experimental work, to be quite frank, you want to make sure that you are thinking about the hypothesis that you want to be testing for. Don't just go and collect random data, but think very particularly about the question that you want to be answering. And so that was the first thing that Ron and I were discussing, was what was the hypothesis that was going to be tested for this experimental design, because it's really critical when doing sensory analysis or any experimental work to know very clearly what was the purpose of your experiment and how is the data that you are collecting going to be helping support that outcome very specifically. So I see a wide variety of different data here and a lot of different potential hypotheses. I wanted to make sure that I was really, really clear about what was the appropriate analysis to be doing in the first place. The first thing I needed to figure out was there going to be any very specific variation between the different data sets? And the challenge for these courses, whether you're in the Wine and Viticulture Technician program or whether you're in Culinary Innovation and Food Technology, is that in general, the students who are in these programs do not have an extensive statistics background. And I myself, I studied statistics while in graduate school, but I'm not a statistician. And so I may be making some assumptions about the statistical analysis that are actually not following the proper math rules. However, as an end user, sometimes we have to make some critical decisions about when are we going to use and apply statistics in a way that's going to help move our agenda forward, as compared to following the rules precisely and exactly as they should be, so that you are having 100% confidence in the data and your analysis. And so if any of my statistician friends are watching, I am going to make a lot of mistakes, and you are welcome to send me some critical feedback. But the first thing that I noted was that this is an unbalanced design, and that we have our friends disappearing from the class every once in a while. So we have a number of absent results. And so this already confounds being able to do the data analysis within the software that we have available to us, in that in general at Niagara College we have access to Excel as our primary statistical analysis platform. Excel is capable of doing a wide variety of different basic statistics. However, this is an unbalanced multiple ANOVA, or you could say it's an ANCOVA, where you need to do regression analysis within your ANOVA platform. Again, I'm not a statistician, I'm an end user, but Excel is unable to do some of this balanced analysis. And so one thing that I had to talk to Ron about was the fact that I was going to throw out anyone who was absent. If they were absent on one day, they were going to have all their data thrown out across both days. And that's perhaps not a fair assumption to make, but because this was a repeated analysis from week 1 to week 2, that's one of the variables that we needed to evaluate, was what was the impact of week 1 to week 2. And secondly, we wanted to look at the different treatments, so the acidity level and the perceived score. Now, when you're talking about perceived score, you're using descriptive analysis on a 15 centimeter line scale. And again, we're also making some assumptions that the panelists were trained to know exactly what these different attributes should be scoring at, so that they knew when a product should be scoring 10 or when a product should be scoring 0 or 5 or anywhere within that spectrum. And as such, we had to make the assumption that they were receiving potentially 30 or 40 hours of training to be able to be repeatable on these sorts of analysis. So from there, I didn't want to have multiple ANOVA with too many different levels of complexity. I teased out that I wanted to first focus on just acidity. So the first analysis that I did was a two-way ANOVA, and what I wanted to look at was I pulled the acidity perceived scores week 1 over week 2, and I needed to recode the data so that I was able to run it through the analytical tools that Excel has available to it. So I recoded the data into the primary variable and the different variables that are out within the analysis. Now, if you're going to be doing different statistical applications within Excel, you first need to find out if you have the data analysis add-in pack. So under data, there is this data analysis tab, and if I click on it, I get all of these wonderful additional analyses. Now, if you are looking in Excel and you're like, wait a second, I don't have that tab, you need to go into the add-ons. So I clicked on File and I clicked on Options. And in here, I have this tab here that says Add-ins. I can go into Add-ins and I can tell if my data analysis tool packs have been added in. If they haven't been, I can go down here to Manage Excel Add-ins and go there, and I can add the data analysis tool packs into my Excel platform. At this point, you may need to start or restart your Excel to make sure that the data analysis tool packs are loaded in there. Now, what I did was a two-factor with replication ANOVA analysis. So under data analysis, two-factor with replication, and in this case, I had my input range, and that was my input range, this whole data set here. So the recoded data, I will share this data set with you so that you can reverse engineer the analysis that I am doing for you. That was my data set. You noted that I had the labels in there. At this point, we had 26 candidates participating, so we had 26 rows per sample. The alpha is going to be the confidence level at which we are going to either accept or reject the data. And from there, I could click on Output Range or New Workbook. I happened to click on New Workbook because I had no idea how big this workbook was going to turn, but I've cut and pasted it for you for the output that came from this analysis. So if I go up here, we've got the analysis up here, and the main output that I really want to look at is this ANOVA table down here, and I've highlighted it in yellow to take a look at these p-values. Main conclusion out of this is that there's a high level of difference across the weeks and across the product. Now, we're not surprised that we're seeing it across the product. We had a low, an unmodified, and a high acid wine that had been adjusted with tartaric acid to give different sensory perception. But what was very important to note was that the week 1 to week 2 variation is extremely significant, and this indicates that the panelists were not very well trained. And again, I don't know if this data is faked or if it was actually collected, but doing quantitative determination analysis, you need to really focus on the training component to make sure that your data is going to be accurate and consistent time and time again. And what's noted from this analysis was that the week 1 to week 2, we had extremely high variation. And take a look there, we see the p-value is extremely small. That e to the minus 37 implies that it is extremely, extremely, extremely small. There's a huge variation across those two different samples. And as such, I did not want to pool the data together from week 1 to week 2 because of that really, really strong level of disparity between the two samples. These are repeated samples, and they were definitely not very accurate from a repetition perspective. That, as a sensory analysis end user means, again, they were not trained well, so that let's say I tasted my sample and I scored it 10 one week, I should be scoring it 10 the second week. What we're seeing is I scored it 10 one week and then I scored it 5 the next week. Maybe my friend Sunan, who's another professor in food science, maybe she scored it 5 one week and scored it 3 the next week. High level of variation rather than us scoring it consistently. When doing quantitative determination analysis, you want to see that you are having well-trained panelists such that if I am scoring 10, everyone else should be scoring very close to 10 as well, because we've been trained well as a panel group. And then we should also see repeatability time over time, so that if I'm scoring 10 on week 1, I'm scoring 10 on week 2. So based off of this conclusion, I felt confident that I could work with just one data set. So I took the data from here and I reorganized it one more time. Now, in this case, I just worked on the week 1 results because, again, I could not pool week 1 with week 2 and do it confidently. So I still wanted to push ahead and do some data analysis. This is cut and paste directly from your data table. But what I first wanted to do was see if, when I did what's called an ANOVA with Tukey's honestly significant difference, was there an honestly significant difference between the different treatments? So when I say A, B, C, and D, we would consider lowest acid A, B, C, and D. I'm going to walk you through how I did this. And ANOVA, again, we can do ANOVA in Excel, but ANOVA just tells us, are the samples the same or are they different? And you would likely say, well, you know what? A should be different than D. And you would anticipate that's correct. But ANOVA just says they're either all the same or they're all different. And that's not exactly helpful. Within a variety of different statistical tool packages, there are ways of doing those side-by-side comparisons to say, is A the same as B? Is A the same as C? Is A the same as D? And those are what are called Posthoc tests. One of the preferred ones to do this is called Tukey's Posthoc test, or Tukey's honestly significant difference test. So I'm just going to walk you through. I use a calculator online, and it's at this web page called astatsa.com, and they have this wonderful one-way ANOVA with Posthoc Tukey honestly significant difference test calculator. I like this one because it's very straightforward to use. So just to walk you through, without overbearing on all the stats, because again, we're not statisticians, we're stats users, I want to focus on the most useful elements of this. So K equals 4, we have 4 columns, and I'm going to click on proceed to enter your treatment data down here. Oh, it gave me some, let me jump back here. I don't want some sample data. Proceed to enter my treatment data, and from here, I went and cut and paste each of these columns. So I'm not doing all the columns, I'm just doing acid. Cut and paste. And cut and paste. Jumping back and forth here. So it's going to do an ANOVA test for me, but again, what I really want to see at the end is which of these columns is different from one another. So I'm going to click on the button, and drumroll please, there's my data table. These are the different descriptive statistics. There's my ANOVA table, and what we're seeing is, yes, there is a difference between these columns, but let's take a quick look. Let's scroll down here. This is really what's the most important thing to note, in that when we look at the comparison of A versus B, they are not different. When we look at A versus C and A versus D, they are different at slightly different p-values. So p at 0.05 for A versus C, p at 0.01 for A versus D. B versus C. So this is the low versus unadulterated wine. There is no significant difference. Whereas B versus D is different, and so on. So what I did was I just copied and pasted these values down here just to walk you through. So just to analyze A versus B across the board, A versus B, no difference on any of these attributes. So whether that's acidity, perceived score, astringency, viscosity, and so on. A versus C, we are seeing difference. That's the one differentiator. So the lowest, the lowest amount of acid versus the unadulterated wine. That's the only one that really had a difference across the board. Now, take a look at this red fruit one. There really wasn't a big differentiator in terms of the red fruit across most of those treatments. That, I think, is interesting. This one also interesting. A versus B is the only insignificant one, but otherwise, you see a very distinctive difference in terms of perception of viscosity across all of the different wines based off of their different acidity values. Now, next analysis that I wanted to do, just to help visualize, I wanted to do a histogram. And so I wanted to see just how does this data spread. In general, when a QDA panel is well trained, you will see very discrete grouping of this data. And just noting that the data for the histogram, if I look at the high acid scores here, we're spreading well across more than 3/4 of the spread on this 15 centimeter line scale. Again, going back to my two-way ANOVA, this shows that the panelists were not coming to a strong consensus on what these products should be scoring as. And that indicates that they did need more training to be able to discretely score the different wine products time and time again. Whether that's the lowest acid or the highest acid, we're seeing a huge spread across all the data. Red fruit perceived score, perhaps it's because of a high level of skewness in this data. Check out the yellow score here. It skews all the way across the data set. Now, how on earth did I make these histograms? Well, let's just walk through the stats for doing a histogram analysis. So within a data analysis, first thing you need to figure out is what are the different bins. And this is a Excel terminology, but really when we're thinking about our bins, we're thinking about that 15 centimeter line scale. And so I'm thinking, going down to my histogram here, this x-axis is the 15 centimeter line scale. And what we're looking at, frequency, is how many times did someone score within that 15 centimeter line scale point range. So this histogram, I needed to set up my bins as 1 to 15. And from there, I can do the data analysis. So if I click on data analysis, I can go to histogram, click OK. And my input range for my histogram is going to be, I had to do this multiple times. So again, this is made for TV. I did it in advance for you. That's my first input range. I want to figure out what would the histogram look like for lowest acid on acidity. So I click on there. My bin range, there's my bin range, highlight 1 to 15. And set an output range. I'm going to set my output range over here so that I don't overlap my data. I can cut and paste it as necessary. And on the first one, I like to do a chart output so that I can see where my histogram data is being collected from, and then I can go back in and add additional data points as I collect more histogram. The challenge with Excel histogram is that you can't do big blocks of data. You have to go line by line. It is what it is, and it's just a little bit of tedium to do, but you can do it no problem. Click on OK. There is my histogram frequency table. So in bin 1, I had 4 people scoring from 0 to 1. I had 2 people scoring in that range, and so on. And somewhere here I should have had a chart pop out. Oh, there's my chart. No, I just clicked on the wrong section. But this helps me visualize the data so I can understand how tightly the spread is on this data. I can also see the level of skew. So in this case, we have a very broad range of respondents going all the way from 1 to 11 within their range. And again, that's an indicator that perhaps this group needed a lot more training before they were going to do this panel. And perhaps that's one of the key outcomes for this. I repeated that histogram step numerous times and grouped my histograms into the different perceived score groups. The last analysis that I did was a radar graph. And this is also an Excel feature. And it is just one of the types of graphs that is within the different charts that are there. And you can see insert surface or radar chart. Main thing about radar charts is that you have to reorganize your data yet again, but it's not, what we're looking at here is the different mean values on the 15 centimeter line scale. And in essence, each of these different axes, you can see it starts 0 at the center and goes out to 15 on the, actually it goes out to 12 because nothing's scored out to 15 in terms of the mean value. But I could adjust my axes out to be 15. The purpose of a radar chart is to look at the potential for overlap and the potential for mapping of the different products. And so you can reverse engineer this radar graph, but you'll see that what I did to organize my data is I pulled the mean values that you had tabulated in your table up here. So these are just the average values, which I had cut and pasted into a nice discrete little table, which made my designing my radar graph a lot more practical. Radar graphs are really nice from a product development perspective to show the directionality of different treatments. We often use QDA mapping for food science projects as a means of either understanding the mapping of products. If you're trying to do a copycat, let's say you're no frills and you're trying to make the no-name product to knock off a national brand. Radar graph using QDA is useful because it can show you where on all the different attributes you're mapping closer or farther away from the national brands from a benchmarking perspective. In this case, you're showing a nice directionality in how you go from high acid to low acid. In this case, high acid to low acid, you're seeing this modification in the expectation on viscosity. Most of the time, if you're doing QDA analysis, quantitative determination analysis, there's going to be additional statistical analyses done, such as hierarchical cluster analysis. And that's out of the realm of the stats software that we have available to us within CFWI. Normally, we'd be using a platform like SAS or JUMP to be able to do that hierarchical cluster analysis, where we can start to see how these products and the different attributes are clustering together. Again, sometimes simple is easy, and histogram is not that difficult. Radar graphs are not that difficult, and being able to do that Tukey's Posthoc, we showed if you're using one of these online calculators, in this case, ASTATSA, not overly difficult. Again, focus on the end result. Don't let the stats bog you down. That said, keep on studying stats. The more math you learn, the more statistics you learn, the more successful you're going to be in moving forward in this technological field of food science. Hope that's useful to you. Take care, have fun, learn stats.